Okay, so this is the final part of P10. If current is flowing, electrons will collide with the atoms, all the positive ions of the metal wire, and when they do, friction and heat will be produced. Okay, so if we want to reduce the amount of energy wasted as heat, we need to have a lower resistance wire. But sometimes it's useful to have a wire that actually heats up. Obviously, it clears our windscreens. Okay, we can also heat up water sometimes. So if you actually look inside your water kettle, you'll actually see a thick coil of wire. Actually, obviously, its main purpose is to actually have high resistance so that we get a lot of heat being produced to heat up our water. Okay, also radiators as well. Okay. Obviously, disadvantages of a wire getting warm, well, you can obviously burn yourself, and obviously where energy just gets wasted. Okay, obviously wires are insulated with plastic around them, so you know it all depends on really the purpose of what you want your wire to be used for. Right, so we've got this next equation. Energy is equal to the voltage times the current, which we'll find out is going to be power in a second, times the time. Okay, so we can work out the energy transferred using this equation. Units are pretty, you know what the units are for the terms. Again, you just need to make sure you're able to rearrange this equation depending on what's given to you in your exam, okay, in the question. So remember, I mentioned V times I. Well, it's this equation here, power. Okay, so the power of a particular device is going to be equal to its current times the voltage, or we can say power is also the energy per the time taken. Okay, it's the rate of energy transfer. Okay, so we have already talked about this. So a large transfer of energy, an amount of energy transferred in a short period of time means that that device is very powerful, and the opposite is true. Okay, if that same amount of energy is dissipated in a longer period of time, is used in a longer period of time, then the power is obviously much less. Okay. Again, watts is the unit of power. Why is more energy transferred when voltage is increased? Well, there we go. If we increase V there, we're going to get a larger power. Okay. And power is obviously proportional to energy. So if we have a larger P, we're going to have a greater energy as well. Okay. So again, voltage is the energy given to each electron. More voltage means more energy. Why is more energy transferred when current is increased? Well, a higher current means more electrons, and every electron has a certain amount of energy. There you go. Pretty simple. Now, if we substitute V equals IR, we're going to get this equation here. Okay, so that means it becomes literally I times IR, which becomes I squared R. Okay. Again, depending on your exam, and also the opposite is true. If you substitute I is V over R, we get V squared over R being power. Okay, so just depending on what is given to you in your question, it's you're kind of like a detective. You're going to have all these equations memorized and some given to you, and essentially you need to be able to determine which equation is best, what's going to give you the correct answer. Okay. So again, just make sure you're able to rearrange these equations. Right, describe the useful energy transfer in an electric motor. Okay, so obviously it's going to be powered by electricity or electrical energy at the start, and obviously the purpose of a motor is to move, so that's going to be kinetic energy. Also, we can get wasted energy in an electric motor in the form of sound, obviously. You obviously will hear the motor running. Thermal energy, pretty usual. And also we'll have some unwanted vibration. So there's going to be some kinetic movement energy that is unwanted. What does direct voltage mean? Well, it means that voltage acts only in one direction. So we also can get alternating voltage, which is when the voltage constantly changes direction. We know that voltage and current are linked, okay? We know that a voltage can cause a current, which means there's also going to be direct current and alternating current. So direct current will be what comes from cells or batteries, so that's current moving in one direction. But we also will get alternating current, that's a forward and backwards motion of the current, and they're going to come out of our sockets, okay? And they come out of our sockets, they literally move back and forth 50 times per second, so at a frequency of 50 hertz and with a voltage of 230 volts. So that's what comes out of the UK plug sockets, and you need to know these numbers for your exams, okay? Okay, so let's look at what actually is inside one of these plugs. So obviously this is black and white, but this should be a brown wire here, okay? And we call it the brown live wire, or just the live wire, okay? You should know it's brown as well, okay? But the way to tell, okay, that it's the live wire is because it's connected to this thing here. This is a fuse. And inside a fuse, essentially, you've got a very, very thin wire, which if too much current, okay, passes through it, it's actually going to melt, which means it's going to actually break, stop further current passing into the rest of the circuit, okay? So, obviously, we've got a power station somewhere in the UK. It's passing electricity into your homes, and the first wire it passes the electricity to, okay, once it enters the socket, is going to be through the live wire, then through the fuse, then possibly into your television or any other electrical device, okay, and it's going to send electrons with 230 volts, and it's going to come back into your socket through the blue neutral wire, okay, so this is the blue neutral wire with 0 volts, okay, because obviously that voltage has obviously been used up. Now there's 1/3 wire, which is called the earth wire, and it's green and yellow, and it's going to have also 0 volts. But the purpose of the earth wire is if there's any problems in the circuit, okay, let's say, I don't know, your electrical device is malfunctioning, it's not working properly, and somehow we've got some excess voltage or some excess current or a surge in current or voltage, essentially it's going to be sent down through this earth wire, which is connected to the earth, okay, and we'll look at why this is more important in the later video. But essentially, it's for safety. Okay, so obviously, you do not, the person near the socket doesn't get electrocuted. Okay, prevents fires, and this is a common exam question. You have to state the purpose of the earth wire. Well, okay, it stops electrocution of the people next to it, and prevents fires, okay? So it's essentially there for safety, and it sends any excess current or voltage right down to the ground, okay, to the earth. Okay, so let's look specifically how the earth wire is useful, okay, because it does come up in a lot of exam questions. So, the earth wire has a very low resistance, okay, and is connected to the casing of the device. So here's the casing of the device, okay, it's got low resistance, meaning, if current's going to pass through it, it's going to have no difficulty actually going through it. However, here's the live wire, the brown live wire, also touches the casing, which means electrons can also pass through the casing. So if anybody touches the outside of the casing, they can potentially be electrocuted, okay? Now, however, and obviously a fire could also potentially be started as well, okay? However, instead of that happening, as the earth wire is also connected to the casing and electrons are drawn to the ground, they're more likely to go through this earth wire, okay, rather as opposed to somebody's hand touching the casing, okay? So that's obviously one way the earth wire is obviously going to save people from being electrocuted or starting a fire. But also, the live wire is connected to the fuse. So as I've mentioned, if we're going to get a surge in electricity, okay, I don't know, a malfunction earlier in the circuit, electricity or electrons are going to pass through the casing into the earth wire, plus through the fuse, but the fuse has got a thin wire which is going to melt, which means your electrical device is going to be safe, okay? Another device which is called a circuit breaker, okay, is sometimes not, it's not in the plug, okay, it could be somewhere further in the circuit or somewhere else in your house, okay, and essentially they also can detect small faults in surges in current or voltage, and therefore they will literally stop the circuit. So they will stop current passing into your sockets if they detect a small fault. But one advantage that they have over fuses is they can be reset. Okay, so with a fuse, you obviously need to go out to the shop and buy a new one if it gets used up once. But with a circuit breaker, they can be reset. Okay. Switches need to be able to break the circuit and stop a current flowing, and they need to be connected to the live wire. So, if you've got a switch, could be to turn on a light, okay, they will be connected to the live wire, okay? And again, obviously, they can turn the circuit on or turn it off, or they allow electricity or electrons to pass through, or not. Again, you should know the difference between the live and the neutral wire, okay? We've talked about that, 230 minus 0, so it's obviously going to be 230 volts, neutral and earth, 0 volts both, each, and the earth and the live is also 230 volts. And finally, what is the connection between the power rating of a device and the energy changes or the energy transfers? Well, the higher the power rating, the more energy is transferred, okay, per second.